Okay, so the next two sections that we're going to do are involving solving absolute value equations, and then the next section will be inequalities. So first of all, let's talk about what exactly does absolute value mean. So a lot of people are familiar with these little bars here, and they're like, oh, well, the number always comes out as a positive. And that's true, but why does it always come out as a positive? What does that even mean, right? So if I have a number inside my absolute value. So let's say I have a 2. A lot of people know, okay, well, the absolute value of 2 equals 2. Well, what if I have a negative 2 inside the absolute value bars? Then people are like, oh, well, it still equals 2 because it has to be a positive. All right, so that's true, but why does it have to be a positive? Well, because anything in the absolute value bars, we're referring to the distance from 0. So if you're looking at a number line, for example, the number 2 is a distance of 2 away from 0, and the number negative 2 is also a distance of 2 away from 0. But if you think about distance, we never use a negative to represent distance. So if you were to go outside and run a mile, you would say, I ran 1 mile. Well, what if you ran backwards? Would you say I ran negative 1 mile? No, of course not. You would still say I ran a mile, I just happened to go backwards. Just like a car. If you look at the odometer in a car, it's always moving forward, measuring or counting the miles that you've driven. Even if you were to put your car in reverse, the odometer would not go backwards or go negative. It would still say you've traveled so many miles. So distance is never going to be negative. Now, sometimes we use negatives on distance to represent which direction somebody went. So if you think about in a football game, for example, if you gain yards, you're moving towards your end zone. If you lose yards or you have negative yards, you are going away from your end zone, but you're still covering a positive amount of yards. You still are running 10 yards or 20 yards or whatever. So distance is always positive. And so therefore, when we put a number inside the absolute values, we're just saying what distance is that number from 0 on the number line. Now, the term absolute deviation, when we talk about deviation, we're saying like how far away is something. So if you think about you're walking down a path, maybe in the woods, and then instead of walking straight, you deviate from that trail. So you kind of leave the path. Well, how far did you deviate? So absolute deviation of a number x from a given value is the absolute value of the difference. So you would just subtract the 2 and then find that difference. And again, you can't deviate a negative amount because it's referring to distance. All right, so with this being said, let's solve some absolute value equations. So if you look at the first example here, we're trying to figure out, well, what number could x be so that the absolute value or the distance from 0 is 3? Well, the absolute value of 3 is 3, meaning the number 3 is a distance of 3 units from 0 on the number line, but the number negative 3 is also a distance of 3 units away from 0 on the number line. So x could be positive 3 or negative 3. So now what happens when we have an equation here? So in this situation here, the number in the absolute values could be positive 9, but the number in those absolute values could also be negative 9 because both of those numbers are a distance of 9 away from 0. And we're saying that x plus 2 is also a distance of 9 away from 0. So what that means is that x plus 2 could equal positive 9, or x plus 2 could equal negative 9 because both of those are the same distance from 0. So now we can solve because we actually want to find out what x equals. So then when you solve it, you do it as you normally would solve an equation and get the variable by itself using your inverse operations. We have x equals 7. And when we subtract 2 from this side, we get x equals negative 11. Oops, sorry. So notice we have 2 different answers. So now let's check it and see why this works. So if I were to substitute in a 7 for this first one here, I would have 7 plus 2 in my absolute values, which of course equals positive 9, and the absolute value of 9, or the distance of that number away from 0, is 9. Now what if I plug in the negative 11? Well, negative 11 plus 2 equals negative 9, and that also has a distance of 9 away from 0. So the absolute value of negative 9 is also equal to positive 9. So therefore, we know that these two numbers, or values for x, are solutions. So let's practice a few more of these. Okay, so solving this first equation, anytime you're saying the absolute value of a number simply equals this, we know that x could equal, obviously, 0.42 because the distance of that number from 0 is the same thing. And we also know that it could be negative 0.42 because that also has the same distance from 0. Now, number 2, we have x minus 4. And we know that x minus 4 could equal positive 13, or x minus 4 could equal negative 13 because both of those have the same distance from 0. So now we're just solving them by adding the 4. So one solution would be 17. And then if we add the 4 to the negative 13, our other solution is negative 9. And finally, our third example, again, we would know that whatever is in this absolute value here, this portion, 2x minus 1, could equal positive 7 because the absolute value of 7 does equal 7. However, the 2x minus 1 could also be equal to negative 7 because the absolute value of negative 7 also equals 7. So then we would just solve from there, adding the 1, 2x equals 8. Dividing by 2, x equals 4. Then the other option, adding the 1, we get negative 6. Dividing by 2, we get x equals negative 3. So notice we have two solutions for every one of our absolute value equations. The only exception to that rule would be if you had something like, for example, if you had the absolute value of 0, well, the only answer for that would just be 0, and so there's only one solution. But in all other values, there would be two solutions. Okay, now sometimes we have absolute value equations where there are other numbers on the same side of the equal sign as the absolute value portion. Now, what I think about when I remember this is absolute values are numbers that are behind bars, and that reminds me of prison or jail or something like that. So I want to get those numbers out of there. However, I can't do that when there's other numbers guarding the jail. So the first thing I want to do is move the numbers that are guarding the jail away. So first thing I would do is do that addition or subtraction piece. So I'm going to subtract the 7, leaving me with a 6. Now, to get rid of this fraction, some people would instinctively want to distribute. But think about this for a minute. Would the guard want to go into the jail? No. So we're never going to distribute a number to an absolute value bar. You would distribute if you have parentheses or some sort of grouping symbols, but absolute value bars are not grouping symbols. They are expressing a distance. So that's why we don't want to distribute anything to the absolute value bars. We have to just get them by themselves by removing things away. So rather than distributing this 1/2, we would use that reciprocal method and we would multiply both sides by 2. That would get my absolute value bars completely alone, the 3x minus 6, and on the other side I have a 12. Okay, so now at this point, I want to find out what is that x equal to. So just like we did previously, we're going to take what's inside those absolute values, and we know that the 3x minus 6 is equal to 12. So the 3x minus 6 could equal positive 12, but what's that 3x minus 6 could also equal negative 12 because both of those are the same distance from 0 of 12 that we have here. So once you write it out the both ways, you add the 6 which gives me 18. I divide by 3. My first solution for x is positive 6. And then I would add 6 to my negative 12, which gives me negative 6. Divide by 3, and x would equal negative 2. Now, sometimes you can have no solution. So let's see what that would look like. So in this example, again, I have this absolute value component, and I want to get that by itself. So I'm going to have to move my, what I call the guard number, this 4, to the other side. So now I have my 2x minus 1 all alone behind the bars, and the other side I have 3 minus 4, which is negative 1. Well, this presents a little bit of a problem because this is saying that the distance that 2x minus 1 is away from 0 is negative 1. And as we said in the beginning, you cannot have a negative distance, so this tells me there is no solution. So if you end up with an equation that's telling you that an absolute value is equal to a negative number, you know that that's not possible, so you just have to write no solution and then move on. So let's just do a couple more examples just to practice with this. So in this first example, I want to get my absolute value part of the equation all by itself. So the first thing I'm going to do is use my inverse operation to move my 5 over. So that's going to give me 2 times x minus 1 equals 14. Then again, we're not going to distribute here, so we're going to divide both sides by the 2, leaving me with the absolute value of x minus 1 equals 7. So now I'm going to solve this the 2 different ways. I have x minus 1, which could equal positive 7 because the absolute value of positive 7 equals 7. But x minus 1 could also equal negative 7 because the absolute value of negative 7 also equals 7. So now we just want to solve for x by adding the 1 on both sides here. And we have x equals 8 or x equals negative 6. Okay, so let's try the next question on the next one. Again, we need to get this absolute value portion of our equation all by itself. So we're going to use our inverse operations, and I'm going to subtract 11. Now when I subtract 11 from 8, I actually get negative 3. And then when I go to divide this 5, I have x minus 4 in the absolute values, but I'm getting a negative 0.6. Or you could even leave it as negative 3 over 5. This tells me that there is no solution to this problem because whatever the distance of this x minus 4 is away from 0, it can't be a negative because there's no such thing as a negative distance. And then finally, number 6. So number 6, we're going to get the 2x minus 3 by itself. First, I'm going to use my inverse operation to add the 4. And that gives me a 5. And now, remember, we're never distributing to our absolute value, so we have to get rid of this 5 by multiplying, or this 1/5 by multiplying by the reciprocal, which is 5. So now my absolute value is all alone, 2x minus 3, and 5 times 5 is 25. So since my 25 is positive, I know that what's inside those absolute value bars could either be positive 25 or it could be negative 25 because both of those would come out and give me this distance that it's saying it's equal to. So that means 2x minus 3 can equal positive 25. Or 2x minus 3 can equal negative 25. Then to solve it, we're simply going to add 3 to each side. Divide by 2. I get x equals 14 for my first solution. And then over here, I'm going to add 3 to the negative 25, giving me a negative 22. Dividing by 2, and x equals negative 11. And that's how you solve absolute value equations.